doing. So I'm going to click on the first one and make sure you write the work in that box so that tomorrow or whenever you're taking your test, you know what you're doing. All right, so I'll do the first one. It says subtract from this. So we're doing subtraction. All right, and remember, if I'm going to the cafeteria from my classroom, where do I start? My classroom, right? So I'm going to the cafeteria from my classroom. I start my classroom. So I start after from. So I start with this. So it's really negative 5x squared plus 5x. All right, minus, because it says subtract, 8x squared, or negative 8x squared, I'm sorry, minus 9. Okay, so that's the question. All right, so we're going to go ahead and ask, is there anybody outside the house? No, so there's nothing that needs to come in. So I'm just going to write this out again. So 5x squared plus 5x. Now, there is someone outside this house, so I'm going to go ahead and distribute it in. Remember, you distribute through multiplication. What is a negative times a negative? So if you forget, a negative and a negative, is that a happy or sad face? That is a happy face. That means that's positive. So this is positive 8x squared. All right, then I go ahead and distribute it because we're not rude. We say hi to everybody. Negative and a negative makes a positive. So that's positive 9. Okay, then we're going to go ahead and combine like terms. Okay, so I'm going to put a box around everything with a squared term. Don't forget the symbol. I'm going to put a box around everything with a squared term. Don't forget the symbol. All right, and then I'm going to go ahead and combine those. And again, you're just going to put this in a calculator. Negative meets positive. They're going to fight. Who's going to win? Positives win because they have more people by 3. So I've combined the box. Bring everything else down. So I'm bringing everything else down. So I've got a positive 5x here and a plus 9. Okay. Is there anything that looks the same? No, because x squared is by itself, 5x is by itself, and 9 is by itself. So nothing looks the same. There's nothing left to combine. This is my final answer. So I'm just going to go ahead and put that into my answer. So 3x squared plus 5x. So 3x. To get the squared is shift 6. Or you can press this keyboard right here and use the squared button right there. So 3x squared plus 5x plus 9. And you can use the keyboard here to type it in if you don't want to write it out. 5x plus 9. Okay. All right, so if you got that question wrong, again, or you don't understand my explanation, you can click right underneath the date, watch help video, and they'll do more than the one example that I just did. But I'm going to go on to the next problem. So I wrote my work in that first box, and I'm going on to 3-step linear equations. So once again, you copy your question down. All right, I'm doing a 3-step linear equation. First thing I do is going to draw a river. Right, I'm going to label boxes. Don't forget the symbol. Boxes with variables, and then I'm going to put circles with constants. Don't forget the symbol. Don't forget the symbol. All right, it doesn't matter which one you move, but I need boxes on one side, circles on the other side. So I'm gonna move my circle to the other side. So if I move -8 crosses the river, it gets wet. It's going to change from -8 to what? +8. Okay. Then I'm going to take the box that's on this side, because now I got circles here and I got a box here, but this box shouldn't be over here. So I'm going to take this box and move it to this side. It crosses the river. It has to change. So it's positive 10x crosses the river. It's going to change to negative 10x. So now it's gone. Okay. So now I look. I have only circles on this side and only boxes on this side. So now I'm ready to combine. Again, you can just use a calculator. Okay. But I'm going to do positives are meeting negatives. What's going to happen? They're going to fight. Positives are going to win because they have more people. By how many? By 2. So that's going to be 2x. Again, put that in the calculator. 12 minus 10 equals positives are meeting positives. What's going to happen? They're going to join. So 8 plus 6 would give me 14. Okay. Then what's my final step? Because I remember I want to isolate x. Then I want to do the opposite of what it is. Right now it's multiplication. So I'm going to divide by 2. So now I get x equals, and again, you're going to put this on the calculator, but you should get 7. Okay, so x equals 7 is my final answer. So I come over here, x equals 7, submit. All right, we're good to go. So once again, if you didn't understand that explanation, click on this watch help video, and they have like 5 or 6 more examples. I'm going to go to the next problem. So I'm going to write that problem down, so in case I forget it, I can use it on my test. So I click on the next problem, and I repeat the process. So it looks like we're still solving equations. This time we have distribution. So anytime we're solving equations, you always have to draw my river, right? Always, always. All right, we do have a house here. Let's go ahead and get into the house. -5 says hello to the first person. We're not rude. So -5 times. All right, so we're going to go ahead and distribute. Oh, draw a river first, always. Go ahead and distribute in a negative, and its distribution is multiplication. All right, so negative times a negative is a positive. Again, you just do your face. That's going to be happy. That's a positive. So -5 times -5, -5 times -x is positive 5x. And then we're not rude, so please make sure you say hi to everybody inside the house. So -5 times -4. Negative times a negative, we just said, is a positive. 5 times 4 is 20. Bring everything else down. So everything else stays exactly the same. All you did was distribute into the parentheses. Now that you've done that, I need to see boxes and circles. Okay, so boxes with my variables, don't forget your symbol, okay? And if there isn't a symbol there, you know that it's positive. All right, here's another variable. Don't forget the symbol. Is there another x? Nope, there's no other x, so that's that. All right, let's go ahead and find our numbers, our constants. Don't forget the symbol. So circle all our constants, don't forget the symbol. All right, the key is to get the boxes on one side and the circles on the other side. So since the box is already here, I'm just going to go ahead and move the circles onto this other side. Remember, when you cross the river, what's going to happen? You're going to change. So you're changing from -5 to +5. This is now changed. All right, I want to move this other circle. Crosses the river. It's going to change from +20 to -20. All right, then you're just going to put this in the calculator. Okay, but we'll do it by hand. Positives are meeting negatives. They're going to fight. Okay, so remember, multiplication is the face, and then adding and subtracting is the teams. So positives are meeting negatives. They're going to fight. Who's going to win this battle? Positives are going to win by how many? By 2. So it's going to be 2x equals. Then we're going to combine all of the circles. And again, you just put it in the calculator, but we're going to do it by hand. Positives meet positives, more positives. So there's 18 positives meet 20 negatives. What's going to happen? They're going to fight. Who's going to win? The 20, the negatives, because they have more people. So that's negative. And 18 people are still going to fight them. So they're going to have 2 left. And then final step, how do I isolate x? Well, the operation between 2 and x, is multiplication. So to undo multiplication, or when multiplication crosses the river, it becomes what? Division. So you just divide by 2. Okay, so you're going to get x is equal to, here I have a negative divided by positive. And again, you're just putting this in a calculator, okay? Negative divided by positive, that's going to be an unhappy face, which means it's going to be negative. 2 divided by 2 is 1. So this is my final answer. So x equals 1. So if I try to type in x equals 1, it tells me, oh, don't do that, just type in the number. Okay, cool. So I come back here and I just type in the number. Boom, and I got it wrong. Okay, so I see why I got it wrong. I said -1. Why did I put +1? That's my bad. I just mistyped it. So x is equal to -1. For some reason, I only put 1. So x is equal to -1. All right, go back. So this is the question. It says solve the inequality and graph the solution on the line provided. So once again, I'm just going to copy the question down really quickly. So copy the question down. Okay, first thing you need to do is you're going to solve the equation. So we're still solving equations. You're going to, this time it's just an inequality. You're going to draw a river. Okay, boxes and circles. So you're going to box the variables. Don't forget my what? My symbol. Is there any other variables? No, there isn't. So a box there. And then I'm going to circle my constants or my numbers. Don't forget the symbol. Don't forget the symbol. All right. Now, on this one, it does matter where the boxes and the circles are because of this inequality, because it's not an equal sign, okay? So boxes need to stay on the left for graphing purposes to make it easier. So we're going to go ahead and move circles to the right. So again, this crosses the river. It gets wet. It has to change clothes. So it has to change from -4 to +4. Okay, so now I have a box here, which is just negative 2x. On this side, I have greater than. On this side, I have 10 plus 4. And if I just put that in the calculator, in case I don't know, 10 plus 4 is 14. 10 plus 4, the calculator will tell you. So once again, you can just put it in the calculator. It's going to be 14. Okay, then I'm going to do the next step. Now, the only difference when you're solving equations and inequalities is you have to remember that if you multiply or divide by a negative, you have to flip the inequality. You have to remember that, okay? That's the only difference. So I'm going to go ahead and keep solving. So right now I'm going to divide. I'm trying to isolate x. I'm going to divide by negative 2. And immediately, because I'm dividing, I look, did I multiply or divide by a negative number? I did. So because I did, I have to do what? I have to flip the inequality. So this is going to change from greater than to less than. Okay, so again, if I multiply or divide by a negative number, flip the inequality. Okay. Now, if it wasn't by a negative number, if this is not negative on the bottom, okay, then I just leave it the same. So put this in, this crosses out. So I'm going to have x. Put this in the calculator, but again, I'm just going to do it by hand. I have a positive divided by a negative. What kind of face is that? It is sad. So it's going to be sad 7. Okay. So x is less than 7. So the reason I wanted you to keep the boxes on the left is so that you can graph it the way I'm going to do it. So you copy your inequality 2 times, the same one, whatever it is. You draw a line from the left and a line from the right. And then you ask yourself, which one of those 2 lines looks like an arrow? So does this look like an arrow, or does this? This one does, right? So this arrow is actually going to be going in this direction. The second question you ask yourself is this. Does that look like that, or does it have an equal sign on the bottom? If it has an equal sign on the bottom, it's a closed circle. If it doesn't have an equal sign on the bottom, it is an open circle. So even if it looks like this, if it has an equal sign on the bottom, closed, open if it doesn't. So in my question, does it have an equal sign? No. So this is just less than. This you read as less than or equal to. Okay, so just less than is open. So it's going to be open at negative 7. Open at negative 7, which is between negative 6 and negative 8. Open, and the arrow is going to the left. All right, so let me go ahead and put it all in here. So what's the inequality notation? It's right here. Oops. It's right here. X is less than, and you're going to write the whole thing. So you're going to write x is strictly less than negative 7. And then to graph it, you're going to do an open over here. So you're going to click. So it says click and drag to plot the line. So I'm going to click and drag. But that's a closed circle, right? So look at where it says click line to delete. So if I made a mistake, I can click that to delete it. What was my number? Negative 7. So it's between here. Okay. Click closed circle to change it to open circle. So my circle was supposed to be what? Open. So I'm going to come here and change it to an open circle. And then submit my answer. Yay. Okay. All right. Then I'm going to go over to the. All right. So I'm going to do the next one, which is determine if set of points is a function. So again, what makes a function is that x does not repeat. Okay. X does not repeat. Be careful, because you do have to read the question. Sometimes it's if it not a function. So what does this question say? Not a function. So I'm just going to find all the ones that are functions. So remember, x cannot repeat. So let's look at all my x values. Do any of these repeat? No. So this is a function. All right, let's look at my x values here. Do any of these repeat? Yes, right here, right? So this one and this one repeats. This one is not a function. So technically the question is which one is not a function. So B is the answer for my question, but I'm just going to keep going and showing you. So again, it is a function if x does not repeat. So you just keep looking at the x values. X value for each coordinate. Does x repeat anytime? It does not. So this is a function. Does x repeat? No, it does not. So this is a function. So it's not a function on B. Why? Because x repeats. You have a 2 here and a 2 here. Okay, so that one is my answer. All right, I'm going to go over to the next one. Determine if the graph is a function. So you're going to click on it. With a graph, okay, you just need to do a vertical line test, or you can write points down, but nobody has time to write points down. So we're just going to do a vertical line test. So to do a vertical line test, all you have to do is draw a straight line down. Does it go through the graph? And this is the graph. Ignore the coordinate plane. This part right here is the graph. Okay, so does at any point this green line go past this red line 2 times? Like, does it hit the red line 2 times? If I just do a vertical line everywhere, does it pass it more than 1 time? It does not. So this one is a function. All right, I am going to find an example which tells me it's not a function. So just hang tight real quick. I'll do another example. Next problem. Or it's not going to let me do another problem. Pause. Next problem. Oh, good. Okay, congratulations, whatever. All right, so next problem. So here's another problem. All right, and again, I'm just going to do the same thing. I'm going to do a vertical line. So I'll draw the original graph. This is the graph. It looks like this and like that. Okay, and I'm looking that every time I draw a vertical line, this is a vertical line, it does not cross that red line more than 1 time. If it crosses more than 1 time, it is not a function. So x is repeated at these 2 points, and I'll just prove that to you really quickly. I'm going to write down these 2 coordinates. So this coordinate right here is, okay, and again, my writing is going to be a little off, but -6, 8 is this one. And then this one right here is -6, -7. And you can see at that point, x is repeating. So that's what a vertical line test does. It makes it to where you don't have to write coordinates down. So if it crosses more than 1 time, it is not a function. So this one is not a function. If it only crosses 1 time, it is a function. I'm going to do another one of this because for some reason I didn't press enter. Let me just submit it. There we go. Okay. Oh, it's because it's supposed to do 3 questions. I got it. All right. I'm just going to do 3 questions actually and just be done. So is a function represents a function. So I need it x not to repeat. Let me do this again. All right. Looking at my x values. Does it repeat? Yes. So this is not a function. X values. Does it repeat? No, this is a function. X values. Does it repeat? Yes, right here. Not a function. X values again. Does it repeat? Yes, right here. So not a function. So the one that is a function is B. So be careful as to what the question's asking, because it can ask, is it a function? Is it not a function? So be careful. Writing equations of lines. Okay, so writing equations of line. All you need to know for writing equations of lines is what a linear function looks like. And this is on your formula sheet in case you forget, but you do need to know what it means though. So write an equation, it must look like y equals mx plus b. It has to look like this, where b is what? By now you're probably tired of hearing me say this. The y-intercept, and m is what? The slope. Once you know that, all it is you're finding what the y-intercept is. So what does that mean? Where it crosses the y-axis. So where does it cross the y-axis? Here's the y-axis. Where does this line cross this line? So I can look for my little crossing right here. So it crosses at 6. So the y-intercept is 6, positive 6. Okay. Now, because it says equation, the word equation, equation must have an equal sign. So an equation, you must write the whole thing. All right, the other piece of information that I need is the slope. Well, how do I find the slope? If you can't do rise over run, which we've talked about before, remember, you go into the formula sheet, you find slope, and then you do what? You put this in decimals, and you let it calculate it for you. What is the letter that goes on top? Y. The letter that goes on the bottom is X. And you put in the numbers and it lets it calculate for you. I'm going to do it both ways in case you prefer one over the other. So I'm going to do rise over run. So I go from this point to the next point. It doesn't matter which side I go, it doesn't matter. I'm just going to go positive because it's easier. When I rise 1, so I rise 1, that's what? Plus what? 1. And then I'm going to run. So I rose 1 and I'm going to run 2. If I went to the right, it's positive, so that's positive 2. Then you simplify this. You put this in the calculator and let it simplify it for you. All right, once it simplifies it for you, it's 1/2 x plus 6, and I just wrote my equation. So basically, find your y-intercept, find your slope, put it in the equation. I am going to put this in decimals so I can show you how to do that. All right, so once again, in Desmos, remember you want to put in Desmos, you want to put the division first and then do the parentheses. So parentheses minus parentheses over parentheses minus parentheses. If you don't, it's going to look funky. And if it looks funky, just correct it. All right, now you just need 2 points. And remember, on the top should be what? Y. On the bottom should be X. So any 2 points is going to be okay, whatever 2 points that you want. So let's say I pick this point right here. Okay. I want the top to be Y. So I'm going to go to the Y value first. That's 11. When I come to the calculator, I'm going to put 11. What does 11 go with? It goes with 10. So on the bottom, on X, I'm going to put 10. Okay, I'm going to pick another random point. Let me pick the one that's over here. Doesn't matter where. So let me pick this one. I need Y on the top, so I'm going to go to the Y axis first. What's that number? 2. So I put 2 on the top because it has to be Y on the top and then X. All right, what does that point go with on the X direction? So I go to X, and what is that number? -8. So I go here, and I put -8. And we should get a half like we did before. Oh my gosh, it's a decimal. What do? You click this circle, and boom, you have the same 1/2 if you were doing rise and running. So whichever method is easier for you, please go ahead and choose that method. It does not matter. So you find your y-intercept, and you find your slope, and then you write your equation. So I write my equation because it's an equation, equal equation. It has to have the equal sign. So I go y equals my slope, which is 1, divide by 2 /2, or you can click right here. In fact, let me click right there and hit divide by 2. And then x. Now, if I put x now, is x supposed to be on the bottom like that? No. So just be careful with what you're typing. Click out of that, then x. And my y-intercept was 6, so +6. So now I'm just putting the information back in here. All right, and looks like there are 2 questions on the test because it says 1 out of 2. So 2 questions are going to be asked of this. So make sure you do enough practice on that. All right, well, I guess I need to finish it. I'm going to do this one just really quickly. So remember, it's y equals mx plus b. I'm just going to go ahead and write it in here so that I have how it's supposed to be written. And then I'm going to put in the information. So I start with my y-intercept. It crosses where? -3. So my plus b is -3. And then I go to my slope. I'm just going to do, again, you can do these 2 points. Actually, as a matter of, oh man, I didn't mean to do that. I am going to do these 2 points really quickly. All right, pick a point. 9 goes with 9. Okay, so 9 goes with 9. So y on the top, x on the bottom. Here's another one. -3 goes with -7. -3 goes with -7. So my m is 3 divided by 4. Why is the answer not correct? -3 crosses -3. 9 goes with, 9 goes with 9. And then what I do, oh, I put my x. Ooh, be careful. It's what? Y goes on top. Okay, so the y value, not the x. So -7. So be very, very careful with that. Goes with -3. All right, y on the top and then x. So it's 4/3. Okay, that's because I didn't write it down. So this is the importance of showing your work. Make sure you write it down. So write an equation given a linear situation. There's only a specific kind of question that I'm going to give to you. So I'm just going to make sure this is one of those. Yeah, this is not the question I'm going to give you. So that's fine. I'm just going to skip it. I'm going to show you just the question I'm going to give you. All right, question like this. This is one that I'll give you. All right, so I'm going to go over a couple of these just to make sure you understand it. I am going to choose the kind of question I'm going to give you. So this one is what it's going to look like. All right, and really what it is just, it's a linear equation in context. Okay, so it's y equals mx plus b in context, where b is your y-intercept, which is, again, your original or your initial or your start, all that, it means the y-intercept. And then m is your slope, how it's changing, your rate of change, how something is changing. All right, so a baby is born with a weight of 5 pounds. So it's 5 pounds, your start or how it's changing. So if I say if a baby is born with a weight of 5 pounds, is that what I start with, or is that how it's changing every whatever? Well, if you're not sure, you read the rest of the question. and began to gain 1.25. So now that you know your second sentence, which one does 5 mean? So the baby is born with a weight of 5 pounds. Starts, okay, so that's 5 pounds is my y-intercept. So a baby starts with 5 pounds and then begins to gain. Now, which kind of direction is gain? Positive, right? So it's going to be plus 1.25 per month. So per month, every month, the baby is gaining 1.25. So if you write that down, your slope, how you change it, it's your gain, which is 1.25. And be careful because sometimes this could be negative. Because it's gain, it's positive. So 1.25 per month, so x is in terms of months, plus your y-intercept, which is 5. And again, I'm going to do a couple of these problems just to make sure that you understand. So that's how you write your linear equation. All right, let me do another one just to make sure we're on the same page. Oh, and please be mindful, I did forget to say, watch what the variables are. So don't use y and x, use whatever they tell you in the question. So you'll see 1.25 plus 5. It's supposed to be t and w because I forgot to look. They told you what it was in the question. So write an equation for w in terms of t. Okay, so I'll be mindful of that when I do this next problem. Let me see if this is one that you'll do. Yes, this is another question, kind of like what you're going to be getting. So I'll go ahead and go over this one too. All right, so Aliyah salesperson. So again, remember you're doing y equals mx plus b. And you just need to find where's my initial, how is it changing? That's all you need. So find your first number. She makes a base pay of 70. What's that? How it's changing or what it is? It is what it is. So that's plus 70 because it's $7 is positive. All right, how is it changing? It's changing at 1.25 commission for every computer she makes. So 1.25, is that positive or negative? It's positive because she makes the 1.25. She doesn't pay 1.25, so it's positive. And then remember, in my previous question, I kept a y and x, but you have to use whatever letters they give you. So write an equation for p in terms of x. So this should be capital P equals 1.25, the one x in the question, x plus 70. All right, so please make sure you use the variables that they're using in the questions. But that's all. All right, so we're going to take a look at table to linear function level 2. So remember, as always, you do need to have, since it is a linear function, you do need to have y equals mx plus b. Okay, so you need to find the y-intercept, and you need to find the slope, and then you can write the equation. Okay, so to find the slope, remember, we did parentheses minus parentheses divided by, and if you do it that way, you see how it's weird, just fix it. So just come here, minus parentheses, wait, up here, make sure it's all under the same fraction, minus parentheses, then come right here and delete that. Okay, so it looks good. All right, then remember what goes on top, y, and on the bottom, x. So y on the top is 7, x is 1, so 7 goes with 1, 7 goes with 1, and 12 goes with 2. 12 goes with 2. So my slope is 5. So right now I have y equals, and my slope is 5x. And the only thing I need to find is the y-intercept. Now remember, the y-intercept happens, okay, and anytime you forget this, you can always just draw a graph and look, because I never remember. All right, so you draw a few lines, okay, so that you can see. Where is the y-intercept? This is the y, and this is the x, right? So this is the y, it crosses over here, right? It crosses over here, it crosses over here. At these points, so let's call that 5, let's call this -1, let's call this -5. At this point, if I was to write a coordinate over here, if I was to write a coordinate meaning x and then y, what would I write for x? At this point, x is always equal to 0, so this will be 0, 5. Over here, this will be x first, so 0, -1. Over here, this will be x first, which is 0, -5. So what you can see is x is always equal to 0. So at the y-intercept, x is always equal to 0. So you can memorize it, or every time you can draw a graph and look at it. So I'm looking for where x is equal to 0. Oh my gosh, I don't see it. But what I do see is I recognize a pattern. You see x each way time you're going over here, you're adding what? 1, right? Every time you're adding 1. That means if I want to go towards 0, instead of keep going down, I'm going to go 5, 6, 7, 8, 9, I have to go what? Up. Now, if I'm going up each time, instead of adding 1, what am I doing? I'm subtracting 1 each time. I'm subtracting 1 to get to 0. So if I subtract 1, the opposite of this, I will get to 0, which means I find the pattern for my y and do the same thing. So each time, what am I doing here? To get from 7 to 12, I am adding 5. From 12 to 17, I am adding 5. Right? I'm adding 5 each time, right? So if I want to go backwards, I'm going to subtract 5. So if I only need to go back one more time, I'm going to subtract 5 from 7, which is going to give me 2. So my y-intercept is equal to 2. So that's 5x plus 2 would be what my answer is. Now, there's some questions that will be more complicated than this, and in a little bit, I will show you how to use, in fact, I am going to show you how to use a Desmos calculator. Why not? You're going to insert, so in this kind of questions, you can insert the table. So you go right here, and you hit table, and then you put in the values. So 1, 2, 3, 4. 1, 2, 3, 4. And then 7, 12, 17, 22. 7, 12, 12, 17. What was that one? I think it was 24, 17, 22. All right, make sure you copy the table incorrectly. All right, once you have that in, because I know it's a linear, why do I know it's linear? Because they tell me it's linear. All right, linear must look like this, right? To put that into Desmos, you have to use this notation. Where you see y and x, you have to put a sub 1. That's what it's called, a sub 1. So you're going to go ahead and put that in. So you're going to type in y sub 1. And if you just do y1, it does it for you. Then instead of an equal sign, so this is just how you use this calculator, you're going to put a squiggly line. And I forget what it's actually called, but look for the squiggly line. Maybe ABC. Yep, right here. Squiggly line is right here. So hit ABC and squiggly line is right there. Then M, then X, sub 1. So put the 1 after it. And then plus B, right? Plus B. All right, when you do that, it's going to give you your M and your B. So if the table is really complicated, you can just put the question in. So once again, you put the table in, you write y equals mx plus b, but you use sub 1 and not an equal sign, but a squiggly line. And it's going to give you what your slope is, which is 5, which makes sense. And your y-intercept was 2. So if the table is not as easy as this, in other words, it's not changing constantly on both sides, then go ahead and just put it in the calculator and see what it is. All right, so that will be my answer, y equals 5x plus 2. All right. Here on graphing by intercepts. All right, intercepts. You know, for intercepts, you copy the question down how many times? 2 times. So I'm going to do my work on Desmos just so I can show you. So you copy the question 2 times, right? Then you block 1. So it doesn't matter which one you block. So let me block, in the first one, let me block the x. So x is no longer there. Okay. Now I solve this equation. So how do I solve that? How do I add? I'm going to take this out for a second. How do I solve this? I divide both sides by what? -10, right? So it's going to be y equals 20 divided by -10. So 20 divided by -10. -2. So my y value is -2. My y value is -2. And be careful to drag it as close as you can. I'm going to repeat the same thing this time for x. So here's the question twice. This time I took out 10y. Now I'm going to take out, oh sorry, I took out y before. Now I'm going to take out, I took out x before. Now I'm going to take out y. So I take out y, cross that out, and I solve this equation. 5x equals 20. You divide both sides by 5. So that's going to be 20 divided by 5. So it's going to be 4. X is equal to 4. So x right here is equal to 4. All right, to check that, of course, I'm going to check it. Control C. Paste it. Control V. Now I need to see if my line looks like this one, right? Zoom out. There's my line. Find my y-intercept is at 4, 0. Is my y-intercept at 4, 0? I mean, sorry, my x-intercept. And then my y-intercept is at 0, -2. Yep. So those lines do match. Okay, find two corners again. All right. Those lines do match. So that one is my answer. All right, so we're going to take a look at graphing lines from equations. Graphing lines is pretty straightforward. Again, everything is y equals mx plus b, where b is the y-intercept. So you go to 4. That's the y-intercept. Then this tells you rise over run, right? And you can put the negative on the top or on the bottom, doesn't matter. So I'm going to put it on the top. -2 in the y direction means I'm either going to go up or 2. Because it's negative, I go down. And then right 3, 1, 2, 3, because in the x directions, remember it's always y and then x, right? So y first and then x, and that's it. But again, you can just do what? You can copy, Control C, and you can Control V. All right, looks funky, so kind of fix it. So I'm just going to do Control X, bring it up here. X out of all of these and just fix whatever that should be. So it should be the fraction is what's missing, and just make sure that you copied exactly what it is. So that's what I think my graph should look like, which is right. Look. All right, so hold on, make sure it goes up. I'm scrolling in like this to make sure it goes up by 1, and then I'm going to make this a bit on this side and put this where you can see it, get rid of that. So I want you just to be able to see this real quick. All right, so you can see it goes over 4, it goes down, and I have a point here at 3, 2, right? So I'm going to see, do I have a point at 3, 2? I do. So I've graphed it correctly. Now, if you are going to get it from Desmos and transfer it over, you just need to find two corners. So this is a corner, put it in. Then come find another corner. This is another corner. So the 3, 2 that I found was a corner. So put that in, but let's say you didn't see that one. Find another corner. Here's another one at 6, 0. So look, 6, 0, put that in. So just find two corners and then you're going to put it in. So if you're using the graphing calculator, that's what you're going to do. But if you're doing it by hand, how I did it is fine. All right, so let's submit our answer. Okay, I'm going to do one more just to make sure we're okay, because it says there are 2 questions on the test. Again, all right, you start at your y-intercept. So where do I start? At 3. And then there's invisible. There's nothing here. So what does that mean? I need to have a fraction. So when you have an invisible like this, you can say invisible 1 over invisible 1. So remember, rise over run. So you go up 1, right 1. All right, again, I'm going to take this and Control C, and I'm going to check it with my calculator. All right, now remember, I just said invisible 1. So you don't have to type this in, but I'm putting this in to show you that it's the same thing no matter what. So where is this graph? Again, zoom out here, zoom out so you can see it. Zoom in so it goes up by 1s. You know, however you need to kind of see. So here's the graph right here. And I'm going to show you that it's going to be the exact same graph without this 1 over 1, because the 1 over 1 does not change anything. So you see the red line and the black line are the exact same thing. So the only reason I write this 1 over 1 is because I want to tell myself to rise 1, run 1. But if you're using the calculator, it's just right there. Find what? 2 corners. So here's a corner. Here's another corner right here. It's a -1, 2. If that doesn't work for you, here's another one. -2, 1. So now I'm just going to go back to my question, make sure -2, 1. Yep, that's on the right. -2, 1 was a corner. And 3, 0, 0, 3, I'm sorry, was another corner. So that's how you transfer it. So you can do it forwards or you can do it backwards, whichever way is easiest for you. All right, so you hit submit. Perfect. All right, the next one that I needed to do was evaluate functions from a graph. All right, so in order to evaluate a function from a graph, remember you're just putting it in. All right, so this is f of what? F of what letter is this? X, which means this is x, right? So when x is 6, what is y? So I go to when x is equal to 6, right? Right here, x is 6, go to the graph. either up or down. I go to the graph right there. I go find out what y is. So y is -5. That's all it is. So y is -5. I'm going to do one more question too, just to make sure, because this is a very easy score to get. Next problem. Okay, blah, blah, blah. I'm doing this one. It doesn't matter what the question is. You're just reading out what it means. What does it mean to write a function? So again, they tell you y is f of x, right? See where the x is? It's inside the parentheses. That means this is x. So this is x, and they're asking you what y is. So go to x, go to -6. Go to the graph. So up or down. So I go to the graph right here. Then I go to y, and I see what my y value is. So my y value is -2. Okay, that's all you're really doing there. All right, last question, graph and linear inequalities. So we already did this in class, but of course, you can just check this by transferring points. Copy, Control-C, paste, Control-V, cross out everything else. So I need to find two corners so I can put it in my equation. So let's find the graph first. So I'm zooming out, just zooming out, zooming out, zooming out, zooming out, zooming out. Where's the graph? Oh, there's an error. Sorry, I don't understand. Okay, so I guess the symbol is wrong. Okay, so I guess when you copy it, I guess it's a different symbol. Just delete it and put it on. Now I see a graph. All right, zoom in so that you can get between 10, because you need it to be in 10, right? -10, -10. So zoom in till it's going up by ones. There we go. And find me two corners. So let's look. There's a corner right here, right? And if you can't move it exactly, you can just look at it. It's -4 and +1. So 1, -4. That's a corner. All right, let me find a different one. So boom, 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 boom. Right here is a corner right here. And again, if you can't get it exact, you can just, look at it. So this is 2, -1, 2, -1, 2, -1. So I'm gonna zoom out just to make sure the graph looks like that. Yeah, it looks like that. All right, now notice it is a dotted line because there's no equal sign, so change it. And then it's small, so the small numbers for y are down here, so you just change the shade because it needs to look like what you have. All right, so we're gonna take a look at identifying quad and linear systems or solutions. These are pretty straightforward. Remember that anytime you have a system of equations, the solutions are the intersections where the lines cross each other. So where does this quadratic cross this linear? So it crosses right here. That's a solution, and this is a solution. So there are two solutions in this case, and every time you write a solution, it has to be in x and then y. So my first solution is my x. So if you forget the x-axis is horizontal, is you come down, that's -1. And my y-axis is vertical. You go to that, that's going to be 1. That's my first one. My second solution is going to be my x value first. So I go to x right here. That's going to be 3. And my y value between -6 and -8 is -7. Okay, so remember, a solution to a system of equations is the intersection when you have an equal sign. All right, so just put that in, -1, 1. All right, it's not going to let me put it in, but I'll just get it wrong and show you. All right, so -1, 1, and 3, -7. -1, 1, 3, -7. Okay, so the intersection is the solution. We're going to take a look at substitution. Okay, so again, we've done this a lot in class, but I'm going to go ahead and do it again. We could do it by hand, but right now what we are doing is copying and pasting, right? So we're going to highlight it, Control-C to copy it, and then you're going to come to your Desmos and Control-V. It's going to look weird, just fix it. Control-X to cut, Control-V to paste. All right, and then just double check that it's the right thing. So 5x minus y equals 21, that's perfect. All right, Control-C to copy, Control-V to paste. And it's looking funky, I'm going to cut this part, Control-X, X out of those, Control-V. All right, then I'm going to make sure it's the same thing. And I don't like that this is the same color, so I'm actually just going to copy again and paste it again. So it's changed the color to blue and delete that one. All right, so x equals 2y minus 3. All right, once you're sure you have copied it correctly, so compare your two equations. Make sure that it's exactly the same. The solution is always going to be the intersection. So you can literally just click on it on Desmos and it'll tell you what it is. So my solution is 5, 4. Now we can obviously do this by hand. In fact, I'm going to get it wrong so that I can show you. All right. You're substituting this part into x. So substitute this part where you see x. So you take this and you put it in here, and then you distribute and solve the equation to get y equals 4. Once you get y equals 4, you plug it back into whichever one looks easier. I'm going to plug it into here. 2 times 4 is 8, minus 3 is 5. You get x equals 5. Okay, so you can do it that way. See, you're going to get the same answer, or by graphs. So remember, by graphs, the intersections are your solutions. All right, same thing with elimination. We can change elimination to be a graphing question. I'm going to select all of this at the same time. Control C to copy, delete what I have, Control V to paste. And then I'm going to come and take what I need. So I need here, Control X, and I'll paste it, Control V. And then here, Control X, Control V. All right, and then I'm going to get rid of this extra line. Make sure they're two different colors. If they're not two different colors, go ahead and Control C again, Control V, and then cross out the extra one. All right, then make sure, okay, always make sure it is what is in the question. Negative 9x minus 7y equals 4, 5x plus 3y equals 4. Perfect. All right, so again, anytime you're doing solving a system of equations, the intersection is the solution. I can't see this really clearly, but if I click into one of these, what happens? I get the dot. Okay, so 5, negative 7 is my solution. So 5, negative 7. Okay, and I'm going to get this wrong again so I can show you real quick how to eliminate. And remember, you could always use your alternate method as well, right? All right, so elimination means you go ahead and you multiply, you line them up, x, y, 4, you multiply 5, and you multiply 9. So you do the x thing, right? Now, always first check to see if you need to multiply by a negative outside by seeing if these are opposite. Are these opposite? Yes. So if they're, because they're opposite, you don't need a negative outside. If they were not opposite, you need a negative. Distribute it in. Let me see my arrows. You're going to get this line. Distribute this in. You're going to get this line right here. Then combine them. You're going to get this line. So then solve for y. So divide by negative 8. You'll get y equals negative 7. And just like before, you plug in negative 7 into any one of these equations, whichever looks easier. So you can put it right here, negative 7, and then you solve for x. So you still end up getting 5, negative 7. All right, you can use the alternate method as well. It's just your preference. All right, solve linear systems graphically. Again, Control C. And I'm actually going to do this both ways. Control C, okay, and again to cut, Control X. Oh, this looked all kinds of weird. What was it? Negative 1/2. Seems like it doesn't like fractions. So when you're copying, just be careful of the fractions. But anyway, it doesn't matter because you're going to look, right? And then Control C to paste, Control V, sorry, to copy, Control V to paste. All right, why does that have that? I don't know why. I'm just going to paste it again. Yeah, because I don't know. All right, so that's my equation. Solve the system of equations graphically, or actually I put in the wrong one here. Oh no, this is fine. Yeah, this is right. Okay, cool. All right, boom. So here's my solution. My solution is negative 4, 6. So my solution in parentheses is negative 4, 6. But you have to put your graphs in here. So you have to copy your graphs from here into here, or you can draw them by hand. So I'm going to draw one by hand, and then I'm going to copy another one, okay, just to show you. So remember, this is your y-intercept. So you start at negative 8. You start at negative 8, and then this says you go down 1, right 2, right? Down 1, right 2. So that would be my graph. Okay, but again, you can just copy your graph straight from Desmos. So I'm going to go ahead and show you how to do that. So my first line, negative 1/2, is what color? Green, right? I'm going to hide the blue one just so I don't get confused. Okay, we agreed in class how we should see these boxes. You can see them as little box, So 1, 2, 3, 4, 5. Or you can zoom in until you see 1, 2, 3. There you go. And these are the boxes. So whichever way does not matter, okay? Just whichever way you find it easier. For me, I'm going to zoom to make the little boxes. So I'm going to zoom out so I can see 5, 10, 15. Okay? Those are my little boxes. So it's each box is 1. I'll take a screenshot of this so I can show you how to copy it. All right, so obviously the first line is always easy because we always agreed we can go to the y-intercept. That's always a nice number, right? 0, -8. So I can copy that line in at 0, -8. All right, it's my second point that I need to find. So again, remember, each one of these is a box right here. So I'm looking for where this line crosses a corner. This is a corner. This is a corner, this is a corner, this is a corner. All right, so I'm going to start going across. Is this a corner? Nope. Is this a corner? Yes, it is. So that crosses a corner. I'm going to go to my x, which is 1, 2. And I'm going to go to my y, which is 5, 6, 7, 8, 9, -9. So 2, -9 is going to be where I go. 2, -9. And you see it's the same line that we had before. All right, then you're going to go to your second one, highlight your second one, hide this one. Again, your y-intercept is easy, 0, -2. So my second line is 0, -2. And then you're going to find a corner. So I'm going to show you a corner one more time. So again, it's going up by ones, right? So be careful how it's going up. So that means each of these is 1. So I'm looking for corners over here, over here, over here. So I start with this line. You can go up, down, you can go anywhere. It doesn't matter. So I'm going to go up and look at that. On the very first one, that is a corner. So that is what? 1. And this is -1. So 1, -1. 1, -1. Oops. 1, -1. 1, -1. Okay. Double check your line because that doesn't look the same. What did I just do wrong? It was at 0, -2, 0, -2. And it was 1, -1, 1, -1. Oh, I went to -1. Haha. 1, x first, -1. So now it looks the same. So always make sure your lines are looking the same. And then make sure that this is the same right here so that you know you did it correctly. So -4, -6 is the intersection. -4, -6, and that's right, so I'm good. So double check your intersection to make sure you copied your graphs correctly, which for some reason I didn't. -4, -6, that's fine. -4, -4, -6. What did it say I did wrong? All right, I'm going to do the long way. So -8, 1 down, 2 right, that's fine. This is going to be minus x plus x minus 2, so -2, and it's going to be 1, up 1, right 1. That's fine. So what's wrong? Yep. Your lines are graphed correctly, but you did not state the solution correctly. Why? Oh, I didn't put the -6, y'all. Oh my gosh. All right, so please be careful. All right, so click on it, look at it. So -4, -6. -4, -6. So please make sure that you copy it down. -4, -6. All right, so that's linear by graphs. Writing a system from context. Okay, so we practiced these extensively in class. So I'm going to go over them again. Okay, remember you can take a screenshot of it just so that you can use a highlighter, and that is control, and then it looks like this button in the middle of your Chromebook. Okay, so you can use a highlighter, because if you highlight it, it's very easy to see. Okay, so you highlight, you find my number, boom, here's my number. Oop, that's not a highlighter. There's a number. What is 250 talking about? It's a game. So 250 is a game. All right, find another number, 375. What's that? A ride, okay? All right, find another number. That's what it is. What's that? Together. So this is a total. All right, find another number. So 12, both rides and games, okay? And just like we did in class, money, 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 money. So money, money, money that all goes together. Okay, so 250. So first let me define my variables. Okay, so what are the things I'm talking about? I'm talking about a game. So let's call it G. And this is the number of games. Remember, it's the number of games. All right, then the other thing is ride. So let's call that ride. And this is the number of rides. All right, set up the money with the money. So 250. So $2.50 goes with G. Plus my rides are $3.75. R equals my other money, which is $36.25. And then when you have four numbers, so this is a four-number example, you set up money, 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 or something, something, something. And then the second equation, the last number is always going to be the variables added together. So G plus R is equal to 12. Okay, and that's it. All right, so let's G equal games, number of games. R equal number of rides. And then you type in those equations. I'm not going to type them in, but you type them in. All right, so the other kind of question that you can get is one with 6 numbers. So 4 numbers, you line up money, money, money. 6 numbers is even easier. All right, so let's find our numbers real fast. Here's my number. What is 5? Peaches. What is 6? Mangoes. Total of the cost. 2 peaches. As a matter of fact, I'm actually gonna do a different color for those. 2 peaches, 3 mangoes. Total cost is 8. So you can see 1, 2, 3, 4, 5, 6. All right, so six numbers. So when you have 6 numbers, you just write it in the exact order that you see it in. So I will let P be peaches. And when it's 6 numbers, it's not number of peaches, it's money. So it's the cost of a peach, something like that. 6 is mangoes. M is mangoes. All right, so be careful not to put numbers in here. These are letters. M is mangoes. And once again, it's not the number of mangoes, it's a cost of mangoes, because this is going to be about cost. All right, and you set it up just like you read it. So this is 5, and then what's this? P plus 6, which is M, equals $17.75. Then you set up the next one, 2 peaches, so that's going to be 2P plus 3 mangoes, 3M, equals $8. All right, so you can see 6 numbers is by far the easiest. You just read the sentence and write it down. And of course, if you were told to solve this, you would put this in the calculator and the intersection would be the solution. All right, so you put those over here. And just a note, it is the price, not number, when it's 6 numbers. All right, so linear systems graphically. Again, copy and paste. Put it in the Desmos calculator. So Control C. Control V. It's pasting it twice. Just cross out one. Control C. Control V. Pasting it twice. Cross out one. Again, if you get the same color, just remember to copy it again. So Control C, Control V. See? Just make sure the colors are different. It's very important for the colors to be different on this one because you need the shading. All right, so we're going to copy. This is unlike an equal sign. So look, I'm going to show you the difference, right? In fact, let me make this bigger. If I had an equal sign, notice there's no shade. And the solution is the middle, right? The intersection. But if I have inequalities, the shading, the intersection of the shading is the solution, not this middle. So do not pick this as a solution. Matter of fact, because these lines are dotted, that is definitely not a solution. It's the intersection of shades. All right, so what do I mean? Let's go ahead and block one out and copy it in. So again, always go to the y-intercept. So 0, -3. Copy that into your question, 0, -3. Then to get my second line, you're going to click right here. It's a nice number. If it's a nice number, copy it in. So -1, 0. -1, 0. All right, make sure you copy this line. Look at this line. It's a dotted line. So this needs to change to dotted. Then where is the shade? Where is the shade? The shade is on the right-hand side or on the top-hand side, right? So you're going to come change shade. That's where it is. So I've copied my first line with the shade correctly. I'm going to come back here, hide the first one, go to the second one. So the second one, the second line, all right, we're going to go with the y-intercept, which is 0, -7. All right, so we're going to graph that, 0, -7, 0, -7. Then this is a nice number. Again, this is a nice number, so it's 7, 0. But those of you who do not get a nice number, you do need to find a corner. So I'm going to take a corner. All right, so I'm going to show you how to do corners one more time. All right, so because it's going up by ones, okay, one little box right here is 1, right? So I'm looking for where the line goes through each of these corners. Okay, so where the line crosses that corner. So starting at the y-intercept, really anyway, it doesn't matter. Find a corner. This is 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 a corner. There's so many corners. So any one of those will work, so I'll use this one. This one is 4 and -1, 2, 3. 4, -3. 4, -3. All right, and again, make sure your line looks the same. I can see mine is dotted, so that needs to be dotted. And then my shade is on the left, right, or on the top, however you want to say that. So change your shade to the top. Now, in order for you to see what I am talking about in terms of the intersection of shades, I'm going to zoom out real quick. I'm going to change this color from black because it's not very clear. Red is nice. Yeah, red is nice. All right, so zoom out, take rid of one color. So now you're looking for the intersection of colors, okay? So here's the intersection of colors. This is green. Where does red intersect with green? Where does red and green go together? So if I put the red one back, it happens right here. Okay, so I'm going to take that off again. So here's green. Where does red hit green? Right here. So when I go into my answer, I'm looking for anything inside here. Stay away from dotted lines. So any point inside here. So if I go into my map, anything inside here, stay away from dotted lines, because remember the dotted line means not equal to. So anything in here. So 0, 0 is a solution. 1, 0 is a solution. This point right here, which is 3, 3 is a solution. This one here, 5, 1 is a solution. Even in here is a solution. 1, -4 is a solution. Any one of those points is a solution. So once again, when you have an inequality, it is not the intersection of lines, but the intersection of color. Okay, so be very, very mindful. Boom. All right, and then it's half-life, whether it's, what was the other one? Double. So for mine, it says a new car is purchased. The value of the car depreciates. And what does that mean? Depreciate means that it goes down. All right, now I did pull up the formula sheet. So this is exponential functions. So I come to exponential equations. And this is that equation right there. The only thing is, though, they don't tell you what these numbers mean. A is what you start with. B is your growth or decay. X is time. So in these kind of questions, for B, instead of B, you're going to go either, if it's decaying in my question, it's 1 minus your decimal. This is after you take your percent and you divide it by 100. That's what goes where B is. And if it's increasing or it's gaining value, it's 1 plus your decimal divided by 100. Okay, so I just wanted to just remind you of that. Then A is whatever it starts with. So for my question, this is what it starts with. It's depreciating, so I'm going to be using this one right here. And it's take the percentage, take the percent divided by 100, and then do 1 minus that percent. And then you'll be, then put X as 12. All right, so I'm going to do it in the calculator, but I did want to show you what that looks like on your formula sheet. So on the calculator real quick. So it is y equals a b raised to the x power. So I'm just showing you what it is. So what is this? What is the value? So it's asking me what is the value. So my starting A in my question is 20,300. All right. Then my B, remember I said 1 minus or 1 plus. So this one is depreciating. So one is going to be 1 minus. And you have to put in the fraction of the percent, which is 8.75. divided by 100, because we got to make it a decimal, then close the parentheses. All right, and then all of it raised to the x power, right? So shift that to the x power, and my x is 12. Okay, so you just put in that in the calculator. Of course, if yours was growing, you would change the minus sign to a plus. All right, if it's compound interest, you'd use a completely different formula. So this is my answer to the nearest cent. So remember, cents is like 25 cents or whatever, right? So you have 6765, sorry, point, and I'm going to write three numbers, 3, 5, and then 3. So cent means I just need two numbers, right? But you first have to see, what does this next number do? So is that 3 going to change anything? No, so this is my answer. If it was a 5, for example, it would change it to a 6. But in my case, it hasn't changed anything. So that's how you round. Nearest cent means two numbers after the decimal. All right, then you're going to go to table to exponential. All right, so again, you're going to put in the table. So your plus sign, insert the table, literally type it in, 0, 1, 2, and 3. Type in the y values, 1, 0.5, 0.25, and 0.125. And we just use this same formula right here, y equals abx for exponential. So everything exponential, here's exponential formula. So this is what it is, y equals abx. So that's what I'm going to put here. So y equals ab raised to the x power. All right, now it doesn't give me any answers because Desmos wants a couple of things that you have to put in. For one, you're telling it, hey, I want from this table for you to give me some answers, but in this table it refers to x as x1 and y as y sub 1. So let's go ahead and do that. So put a 1 after the y, and every x needs to have a 1 after it. Okay, now that got rid of the numbers, meaning there's one more thing that it doesn't like, which is this equal sign for some reason. We're going to delete that, and we're going to put a squiggly line. So you're going to press the keypad, A, B, C, and then squiggly line is on the bottom right. Once you do that, notice your answers have come in. So to transfer your answers into Desmos, you're going to go ahead and type in what you would have before. Y equals ABX, right? So, and I did shift 6 to get the power. So what's my A value? A is 1. So instead of A, I'm going to put 1. I like to put B in parentheses when I do mine. Instead of B, I'm going to put 0.5. And it says an equation in general, so I don't need to change the X. Now, I don't know if this is going to be right because this is an invisible 1, so technically you can take that off. But I'm just going to leave it there and see if Delta Math cares. It does not care. All right, so that's how you go from a table to an equation. And while I'm on this, any table, okay, you can go to the exponential or you can go to linear. So linear, you'd use this equation and it will give you M and B. Or you can go to quadratic and put this equation in right here, and it will give you A, B, and C. So same process for every single table. All right, so let's take a look at half-life and doubling. Okay, so remember it's pretty much the same formula as before as an exponential function y equals abx. However, you are going to have to remember that the difference with your growth or your decay is halving or it's doubling, and there is a little bit of a difference on how you write the time. So let's go ahead and do this question. All right, so a new car is purchased. So I'm going to write my general formula out. Y equals A, parentheses, B, raised, shift 6 to the x power so that we are aware of what it is. All right, so a new car is purchased. Okay, so where does that go? Is that my A, B, or X? That's going to be my A. So that's 18,000. Over time, and its value depreciates by, so it depreciates, it's going down by 1/2. So it's telling you, this is half-life, that B is going to be half. So you can write 1 divided by 2, or you can write 0.5. Every 6 years. Okay, so every 6 years is going to depreciate by 1/2. What does that mean? That means in year 1,
So it's depreciating by half every 6 years. That means in 6 years, this 18,000 is going to go down by half. So it's going to be 9,000. But this is after 6 years. Then again, it's going to depreciate again. So year 6, then it's going to be year 12. It's going to depreciate again by half again. Okay, so that's what the question is saying. But it's not asking you when is it, what's your answer in 6 years or in 12 years. Instead, it's asking you about 19 years. So 6 years from now will be 18 years. Half of that will be 2250. Okay, so that's not quite 19. So it's going to be close to this number, but not quite 19. Well, there's a little bit of a formula that we can use to figure this out instead of manually doing it by hand like the way we're doing right now. So quite simply, when you put it in here, you'll put your 18,000, you'll do 1/2, just as you've done right here. However, your time is what's different, because notice you have time here and you also have time here, right? And all that you need to know for that is that when you're putting your time in here, it's going to be your total number of years over your half-life. Or if you get a doubling question, your double. Okay. Now, the only difference between your double and half-life is right here. I've put half because it's half-life. If it has double, I would put 2. Okay. All right. So when I come to x, to put that in parentheses, because if you don't put it in parentheses, it comes out of there for whatever reason. So I need the total number of years. What's my total number of years? 19. Okay, 19 divided by my years of my half-life or years of my double. In this case, it's every 6 years. And really what you're doing is you're just finding out your, how do I make this bigger? You're just finding out exactly what this number is. So it's going to be close to this 22. Can you see that? 2,000 was close to that 2,250 because that was 18 years, not 19 years. Okay, so to the nearest $100. Okay, so this number is 2004.522111582. All right, nearest $100. Remember what we were talking about, okay, in class. This is the nearest dollar, the nearest tens of dollars, the nearest hundreds of dollars. So this is really what I'm looking for. Nearest hundreds of dollars is right here. Okay, because it's 2,000, no hundreds, no tens, and $4. So the nearest hundred, is this 004? Is this close to $0 or is it close to $100? Well, it's close to $0. So this will be 2,000 to the nearest $100. So you come here, 2,000. All right, and again, the same thing as, let's see if, all right, in fact, I'll do this question as well, because this one is a double, right? So the same thing, exact same thing. So your starting point is, is your A, so 2,200. Instead of halving it now, I'm doubling it. So the number is 2. The total number of years, which is in this case, or time, the total number of time, which is 13 hours, over the amount of time it takes to double or to half, okay, which is 6. And so that answer is 9877, blah, 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 to the nearest whole number, which means what? No decimals, right? So if there are no decimals, you look at this number right after, okay? 5 and above, add 1 more. 4 and below, just ignore. So this is 5 and above, so it's going to add 1 more, so it's going to be 98. So adding $1 here will be 9878. 9878. And I don't know if it's going to let me submit this 9878. But we'll go ahead and try. And it did. Okay, so the only difference, of course, is doubling or you're halving. But it's a total number of years over the time it takes to half or double. All right, let's take a look at compounding, solving for a future value. So this is straight out of a formula. So what I'm going to do is I'm going to look for the formula for compounding. So it's an exponential equation, but it's a special kind. And it's this formula right here. And you just need to know what each of those things are. So I'm going to type it out. Capital A equals capital P 1 plus R divided by N close the parentheses, then shift 6 or hit this button right here, then NT. Now realize, oh, actually it stayed up there. That's fine. Okay, cool. All right, so you just need to know what each of these things are. All right, so I'm going to go over it as I do my question. All right, A is your final amount, what you end up with at the end. P is my principal, what I start off with. R is my interest rate, but remember you cannot put a percent in there. You have to divide it by 100 before you do that. N is the number of times that it is compounded. In other words, if it is compounded monthly, it is 12 times that it is compounded within a year. So it's the number of times compounded within a year. So if it's compounded daily, it's 365. If it's weekly, how many weeks are there in a year? 52. If it's yearly, it's 1, and so forth. And then T is just time. So let's put in the numbers that we know. Sarah invested 38,000. Invested. So that's the money she's putting in. That's your principal. So 3,800, sorry. In an account paying an interest rate of 3.6%. So that's my interest rate. That's my R. However, you cannot put percent in there. So before you can put percent, you must get rid of that percent. And how do you do that? You divide by 100. So that's 0.036. 0.036. All right. How many times is it compounded? It's compounded daily. Okay. So how many days in a year? 365. That's your N. Okay. And I see an N here. So that's going to also be 365. And I'm just going to put, you can put multiplication or you could put parentheses, however you want for the time. All right. Assuming no deposits or withdrawals are made, how much money to the nearest $100 would be in the account after 15 years? And so T is equal to 15. Boom. So take out the equal sign and it's going to give you a number to the nearest $100. Okay, so to the nearest $100. So that just means so we have 6, 5, 2, 0.652 nearest $100. Again, this is your ones, your tens, your hundreds. So nearest $100, we're concerned about this number right here. We are between $500 and $600. Where is 520? Is 520 closer to 500 or is it closer to 600? So hopefully you said it's closer to 500. So that's going to be $6,500. $6,500. All right, so the formula is about knowing what each thing means. So that's solving for a future value. But if you're solving for your principal value, that means you're solving for P. Again, you start off with the formula. So I'm just going to put the formula all the way back. All right, so this is our formula straight from this reference sheet right here. You just have to know what it means. So let's fill in all the numbers we know. Terry is going to invest in an account paying an interest rate of 4.7%. Okay, so that's an interest rate, so it goes right here. But again, remember, you cannot put interest, the percent in the calculator. You actually have to find out what it is. So that's 4.7 divided by 100. And that's the number you put in as R, so 0.047. So you come right here, delete 0.047. It's compounded monthly. Okay, so how many months in a year? 12. So that's your N. N is the number of times it's compounded. So it's compounded 12. And then let's go ahead and put multiplication right there. All right, and then how much would Tyree need to invest the nearest dollar for the amount to reach 98,000? So this is equal to 98,000. So the question is, and is there a time? Oh, here we go. To reach, I was wondering what the time was, to reach 98,000 in 8 years. So the time is 8. So we are solving an equation for P. All right, for you to understand this, it's really some basic algebra that you need to understand. Like, let's say, for example, I had 10 equals P times 5. And I asked you to solve for p. What would you do? You would divide both sides by 5. So you would say, and I'll just copy this line here so I can show you. You would say this side divided by 5. And then this side divided by 5. Oops, not like that. Hold on. Oh, divided by 5. P times. All right, because these two 5s would cross out, leaving just 10 divided by 5, which would be 2, which is equal to p. So p would be equal to 2. And what you would have done is just divided both sides by 5 to isolate p. Well, look at it here. This is your 10, and all of this is just a number. This is just a number. It's, say, the number 5. So what you need to do, you need to divide both sides by this number. And I'll prove to you that it's just a number. So I'll put it right here real quick. You see, it's a number, right? So it's just like this number 5. So you would divide everything, or you would divide both sides by p. So what I'm going to do is take that 98,000, sorry, divided by this number here, which I'm just going to control and paste. So this is going to give you equal my p. So I just solved the equation, right, for equal p. So this is p right here, my principal amount, and I need to round that to the nearest dollar. Okay, so I need to round that to the nearest dollar. All right, so to the nearest dollar. All right, so no cents. Nearest dollar means no cents at all, right? So this is my cutoff point. All right, these are many dollars as I have. I look at this number here, 5 and above, add one more, 4 and below, just ignore. So this is 4 and below, so you're just going to ignore. So the answer is 67,336. All right, so we're going to take a look at finding average rate of change from a table, equation, and a graph. And really, if you can do one, you can do all. All right, the table is easy. So remember, average rate of change, you need box. So in my case, you're going to do parentheses. Then it's parentheses minus parentheses over. So I'm going to do divided first. So you got to do divided so I can do that. Parentheses minus parentheses minus parentheses. All right, then minus parentheses. So once you have that set up, parentheses minus parentheses over parentheses minus parentheses, they're always going to give you the x values. And remember, we're going off of, what is this? Slope, right? Average rate of change. So if you go look right here, average rate of change, it says the change in the y divided by the change in the x. And if you look to the left, they give you the values. So you can see x on the bottom, y on the top. So x on the bottom, so x, and it looks like it's which x? X2 first, so the second one. So the second one is 13. So 13, and then the first one, which is 4. So x on the bottom. Then all you have to do once you put that in is match it for the y. So I'm going to go look for 13 in the table, right here. What's the y value? 30. So you're going to match that to 30. Then you're going to match 4. What are you going to match 4 to? 48. Once you put it in, that's your answer. You're done. All right, so that's from a table. Then when you do it from a equation, it's the same thing. You're just going to copy and paste it. Control C. And I'm going to leave this up here because I need it. Control V. All right, then, fix whatever needs to be fixed. Like, I don't need that at the end. All right, something has come up. All right, so once I get an equation, now that I know how to do it from a table, all I need to do is make this a table, right? To make that a table, click on the settings, hit table, and now it's a table. And now you're looking for your intervals again. So once again, I'm going to delete this. So it's parentheses minus parentheses over parentheses minus parentheses. Make sure that that's what it is and not this. This is something different. If you have this, this would be wrong, okay? So make sure that that division bar goes over the whole thing. All right, so now I'm looking for, again, the first number, if you forgot, is the second x and then the first x on the bottom. So second x is 11. So that goes right there. First x is 3.
and then match it. So I don't see an 11 here. Oh my gosh, just come in here and type it. 11 is 21. And then 3, if I don't see a 3 there, just come to any number, type 3, it's 53. So once again, it works it out for you, and that's -4. All right, so all these questions are really the same thing, but from 3 different values. So, all right, find domain and range with technology. So let's go ahead and Control C, and then Control V, and then kind of change it up. Control X will cut, Control V will paste, Control X will cut, Control V will paste. But that doesn't look the same. I need to put a square root, so I'm going to go here, put the square root, and inside that needs to be the X. So just make sure that you've copied down exactly what it looks like. All right, range. Range, remember, is bottom to top, right? It's your Y values. And then domain is your X values. I don't see a graph here. I'm going to press home. It's going to zoom in with my graph. So I'm going to actually do both domain and range, just depending on which one you get, right? So once again, domain is X, range is Y. So range is Y values, and domain is X. If you're looking at the X-axis starts from the left-hand side and goes to the right. And then if you're looking at the Y-axis, starts from the bottom and goes to the top. That's what you're looking for. So if my question was asking me for domain, where is my graph starting? Right here. And because I'm doing X, I'm going right and left. Where does it go? Like this. So it starts at 5. Does it include 5? Yes, it does. So that's closed. And where does it stop? Infinity. Okay, does it include infinity? No, because that's not a number. All right, in terms of range, so now I'm going to do range. It's the same process, only you're going from the bottom to the top. So let's start from the bottom of the graph. That's the bottom, right? So what's the bottom? Oh, I did domain wrong. Y'all, I'm tripping. Domain is this way, right? So that number is 0 to infinity. My bad, my bad. I don't know why I said 5. All right, so my domain is my X values. So it starts from 0, because that's where this graph starts, from 0, and it goes to infinity. And then my range is my Y values. Okay, so starting from here, the bottom, so starting from the bottom to the top. So it starts at 5, and it goes this way forever, because this graph keeps going up and up and up and up. So it starts at 5. And it goes towards infinity. And I'll do another question just in case I confused you on this one. All right, and then that's how you write it. And you can write it two ways. So you can use interval notation, which is what I just did, but I'm going to write it in terms of inequalities. It's going to be y is greater than, and it's not 5, it's -5. Y'all, I'm just tripping all the way around. -5. So I'll do open and close, and I'll say it's going from -5 to infinity. All right, I'll do another problem because, oh, I can't do another one? Hold on. Oh, good, I can. All right, so I'm going to do another problem because I might have confused you with that. All right, so +1 -4. You just put it in. Once you put it in, you just look at it. All right, so find the domain. So this is the X values, right? So we're going to look at the X values. So starting from here, so it's left to right, right? X values left to right. So starting from here, it goes like this forever, right? But look at the values. So that's this number here, which is -1 to infinity. Then if I was looking at, so I'll go ahead and put that in there. So -1 to infinity, open and closed, -1 to infinity. And then if I was looking at the range is from the bottom of the graph. So the graph starts right here. Whatever number this is -4. And it keeps going this way forever because it's still climbing all the way here. So the range would be -4 to what? To positive infinity. And then this would be a number, so that's closed, and this is open. All right, but that wasn't my question. My question was the range. So boom. Next. We're going to take a look at the last one. All right, so looking from a graph, again, the same kind of idea. All right, so what's my second? So I'm going to come to my boxes here or my parentheses and delete all the numbers.
All right, and they tell me my second one is 2. That goes over here, and again, if you forget, just come to the formula sheet right there. In fact, I should do this. All right, so right here, the second one goes first in the bottom. So 2, and then the first one in here. And you just have to find what those matching equivalents are. So when x is 2, what's y? So when x is 2, right here, y is 0. When x is 1 right here, I go up to the graph, y is 10. All right, so again, to read the graph, you just go to it. So when I'm finding x is 2, I go right here, y is 0, y 1. When x is 1, it's 10. If x was 7, I'd go to x is 7, go to the graph, and then y would be 40. If x was -2, for example, I'd go to -2, go to the graph, and y would be -32-ish, but they won't ask you for something in between. And that's pretty much how you do all of those questions. So you can do all of those questions relatively fast. All right. Next, common ratio and common difference. All right, so this is whether you know something is geometric or arithmetic. Geometric, you're constantly multiplying to get the next number. Arithmetic, you are adding or subtracting to get the next number. And if it's neither, then you're not doing anything. What does it say? Find the common ratio of the sequence. Okay, so I'm finding the what number am I multiplying each time. To do that, you always take the second number. So the second number, because it's multiplication, the opposite is division. Second number divided by the first number. So -2, and now I'm just going to check it. What that is saying is when I multiply it by -2 every time, I'll get the next number. So if I did times -2, I get -18. If I take -18 and I multiply it by -2, I should get 36, and so forth. So yes, that is the pattern. So the common ratio here is -2. What am I multiplying by each time? And if it was addition, if it was, let me see if they actually have that. Oh, it doesn't give me a next problem. What if I did show example? Okay, common. So if it was an arithmetic sequence, it would mean the second number minus the first number will be a common difference. Second number minus the first number, which is 5. So my common difference is 5, meaning every time I add 5, I get the next number. See? Common difference is 5. So second number divided by the first number if it's geometric. Second number minus the first number if it's arithmetic. All right. Distinguish between those two. So are you adding and subtracting, or are you multiplying each time? So looking from 3 to 12, am I multiplying? Looks like times 4. If I do 12 times 4, will I get 48? I don't know. Let me check. All right. So 12 divided by, so second number divided by the first, and then the second number subtract from the first. All right, so it could either be a multiplying by 4 or I'm adding 9, one of the two. So let's check. If I do 3 times 4, I get 12. If I do times 4 again, do I get 48? I do. Whereas this one, I'm adding 9, right? So this one is saying 3 plus 9. I get the next number 12, but if I add 9 again, do I get 36? I don't. So this one is geometric, and the sequence is a common ratio, and it's equal to, what was I multiplying by? 4. Okay, so once you decide which one it is, you answer the questions. All right, select an explicit formula. So remember, we talked about how we're just going to use the multiple choice. These are test-taking skills. We're just going to use the multiple choice to see what it is instead of doing it from scratch. So the question is, what is the formula for the nth term of the given sequence? So these are all the different formulas. The thing to remember about these formulas is that n is the number of terms. So this one is the first term, this one is the second, this one is the third, etc., etc., right? So what you're asking yourself to do is, when n is 1, all right, when I put 1 there, will the term that I get out be 4? So if I put 1 where I see n, will it be 4? So what you can do in terms of putting this in Desmos is you can just copy the right-hand side of each equation for every single one. Because we're doing multiple choice, right? For every single one, so that I know which one the answer is. And I'll copy them in order so I can keep the answer the same.
All right, and then this is to the power, so make sure you fix it to the power of, boom. All right, so those are my 4 answer choices. And now I'm going to say when n is 1, do I get 4? So I come right here, and I do 1. Did I get 4? I did. All right, what about the second term? So if I put the second one, will I get 1? So if I put 2, do I get 1? I do. And if I put 3, do I get -2? I don't. Okay, so A is not the answer. So now I'm going to check B. Wherever I see n, put it in parentheses. I'm going to put the first term. Do I get 4? I don't, so it's not that one. I'm going to go to C, put parentheses for where n is. So that's what I'm doing. Put in parentheses where n is and put in 1, 2, and 3, and do I get these numbers? So 1, do I get 4? I do. 2, do I get, no, I need to get 1, not 7. So the answer must be this last one. But I'm going to check. So again, where n is, you're going to put parentheses, and then you're going to put it on. Okay, so when n is 1, I get 4. When I put the second one, do I get 1? I do not. Okay, so that wasn't the answer. So I must have made a mistake. And it looks like, why did I put -2 here? It must have been 2. All right, so I'm going to check again. So if it's 1, it's 4. If it's 2, is it 1? Yes. And if it's 3, it's -2. So the answer is actually A. I'm tripping. So remember, all right, this is, n is just the number of terms. So this is the first one, the second one, and the third one. So when you substitute the first term, the first one, do I get 4 as the answer? When I substitute this for the second one, do I get 1 as the answer? When I put the third one, do I get -2? Okay, that's really all that you're doing. And then once you do that, you match it up. All right. Select recursive formula. So again, we're working backwards. Okay, what this one is saying, which recursive would produce this sequence? So they tell you that the first one, the first term is 3. And then they're asking you in general what happens. So let me go over, because this one's not really a calculator, it's just understanding. This is saying this. When I do say, so they say the first one is that one, right? So now I'm looking at the second one. So this is the second term. So when I take the second term, when I'm looking for the second one, and then I subtract 1 to it, I'm going to get the first term. So what this is saying is -2 times whatever the first one was, which is this, then -3, is that going to give you 3? That's the question. Okay, so I'll put that in the calculator. So I have a -2, and again, I'll do the same thing for all of them. -2, and I'll leave this part blank because that's what my substitution is, and then 3. As a matter of fact, can I just kind of going to go 4 times and then change it. All right, the second one is -5, and then -2. Third one is -3, -2. And the last one is -2 minus 5. All right, so what it's saying is, when I put the term before it, right, that's what this is. Put the term before it, do I get the next one? So they give you the first one. The first term is 3. So you see all of this is 3, right? So when I put in that first term, so when I put in 3, do I get the next term? So I should get, when I put in 3, I should get the next term, which is -11. Which one of that gives me that? So these last two. So now I'm looking at these two. When I put in the term, so now I'm on A2, right? A2 is now 11. So when I put in that term and do this to it, do I get 17? So now when I put in the next term, which is -11, so right here, because these are the only two that are working so far. So -11 and -11. Do I get the next one, which is 17? Only on the last equation. Okay, so I'm going to say that again because actually I'm going to do a different example. Let's see, let me get this wrong so I can do another one. So yep, it was the last one. I just want to do another problem again. So I'm going to copy down what it is. So with parentheses where the previous term is. So this one is 4. This one is +4. This one is 2 and 3. We might as well delete all of this. And this one is 4 and -4. This one is 3 and +2. All right, so same thing as before. When if I'm looking for the second term, when A is 2, 2 2 minus 1 will give me 1. So this is negative 4 times the first time plus 4. Okay, that's how that reads. So when I look at it, when I put in the first one, which is 6, so I'm put the first one 6. Do I get 20? That's the question. Okay, so 6, 6, 6, and 6. I only get 20 on the last two. So it's not A, and it's not B. So it's one of these two. Now it's saying when I put 20 in there, will I get 76? That's what that is. So I only need to do it on the last two. So when I put 20, 20, which one gives me 76? C. So this is your answer. Just that easy. All right, so we're going to take a look at plot points and graph exponential function, no table given. All right, this one, it's actually not as sensitive as it seems like. So it says use technology, right? So we're not going to plug in numbers. We're going to copy, Control C, and then paste it into Desmos, Control V, and it doesn't like it at all. So I guess I have to type it in. So I'm going to go ahead and type it in. So it's y equals 2, raise the power, Shift 6, or you can click it over here. Now notice if you don't put parentheses and you try to put that minus 4, it comes down automatically, right? So to keep it back up there, just put it in parentheses. So parentheses will keep it up at the top. So x minus 4. And then minus 9. So I'm just, again, copying the question into the calculator. So it's graphed it for me, right? Now I have to plot at least 5 of those points. So I can come and look at the graph. So 2 things you could do. You could click this right here and click table. And unfortunately, sometimes they're good points and sometimes they're not. So this is not a good point. So because it's not a good point, I'm not going to use that. I'm going to look at the graph. So I'm going to make this a little bit bigger so I can plot my 5 points. I might have to just make it full screen and come down. What I do is I start at my isotope. All right, so where's my isotope happening? So zoom in or zoom out until it's going up by like 1. So this is 8, 10. So I need to zoom in. So zoom in. All right, there it's going up by 1s, right? So find up where it's going up by 1s. All right, so find your graph. So mine's at -9. Okay, and you know it never touches because look at this point right here. You think it's touching, but if I zoom in enough, hold on, let me keep zooming. See, it's not touching because that's an isotope. All right, so I'm going to press home just to go to the normal graph, move my graph up, and then zoom in till it's going up by 1s because I need to be able to read my graph. So my isotope is at -9, and then I'm going to keep going until I find a corner. Now, just to be clear, just to say this, for the 100th millionth time, a corner occurs, okay? So if you see it's going up by 1, this big box right here is 1. So I'm looking for where this graph passes either here, 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 or here. That is a corner, this big box, because I found my numbers. See, it goes 8, -8, -7. This is 1, okay? So that's what I'm looking for. So I come across, and I'm looking for the corners of the big box, big box, big box, big box, right there. That's 1 point right there. Okay, so I'm going to go back to my graph so I can find it. So that's going to be here. And if you kind of click on it, you can get real close to whatever it is, or you can read it. So it's 4, -8, 4, -8. And then what you're going to do is go back to your graph and put that point, 4, -8. And you're going to repeat this process 5 times. Okay, so now I don't need that. Put up my Desmos calculator. Okay, so that's my first point. Oh, look at this. Somehow I managed to get my point to stay on the graph. How did I do that? Y'all, it was by accident. I don't know what I did. Oh, it's gone. All right, so corners. So there's my corner. That one was 4, -8, right? I keep going. Here's another corner right here, because remember, it's the big box. So a corner right here. That looks like it's 5, -7. And again, you can look right above it, 5, and then to the left, -7. So 5, -7, 5, -7. So I need 5 of these points. So I'm just going to keep going until I have 5. So I'm going to move my graph a little bit more. So I'm going to keep going. That's not a corner. This is a corner. So I can look at the numbers 6, -5, or I can click and kind of get it to where it shows me. 6, -5 is my next one. 6, -5. All right, then I'm going to go to another corner. So I already got that one. So keep going, keep going, keep going, keep going, keep going. Here's a corner right here. 7, -1. So you look right here, 7, -1.
7, negative 1. So I have 1, 2, 3, 4. I need 5. So I'm going to do it one more time. I'm just going to move my graph over. So that's not a corner, that's not a corner, that's not a corner, that's not a corner. Keep going. Oop, there's my corner right there. So what's this corner? 8, 7. So now, because I'm on the positive side, 8 is over here and 7 is over here. So 8, 7 is my last point. 8, 7. Okay, so those are my points. I say done plotting points. Now look, this is not as sensitive as you think. Remember, my isotope, it happens at -9. So you do need to know your isotope. I'm going to press home just so it can come back down. You do need to know your isotope. I'm going to zoom in. See, mine is -9. As long as when you start curving, you see this? You curve it into the isotope. Curve it into the isotope. Don't just like drop. Curve into the isotope. It's not going to care if you're accurate or not. All right, so watch. I'm going to draw this really, really badly, okay? So I'm even going to miss the points. See this? See this? See this? I'm going to kind of miss the points a little bit. All right, this is the most important part. Curve into -9, and then don't go underneath. You can see, right, how bad my graph is. It's going up, it's going down, it's doing all of this. I missed this point. As long as your arrows are going for forever that way and forever this way, and you curve into the isotope, you should be good. So let's go ahead and check this out. So submit my answer. I guess you're not good. So if you're not good, it will tell you why. Okay, so it does care, okay? So yes, you do need to make sure you kind of hit the points, because it's telling me basically I got it wrong because I didn't go through that point. So it does care about whether I hit the point. But here, I didn't quite hit this point, but I guess it's not that far away. Okay, so I'll do another one just so that you don't think we got it wrong for real, for real. I'll do this one a little bit faster so that we're not spending so much time on it. All right, so the very first thing you do, of course, is copy the question down. So 2 to the x minus 3. All right, remember you can click table. My points are nice now. If they're not nice, you can just read it off the graph. So I'm going to read it off the table since my points are nice. Not the decimals, of course, just the whole numbers. So 0, -2, 0, -2. 1, -1, 1, -1, 2, 1, 2, 1. And I need 4 points on this one. So I'll just go and say 3. Ah, that works. 4. See, 5, 6. These are different points, right? So 3 is 5. 3 is 5. So those are 4 points. All right. So now we're back to the drawing part like we were doing before. I need to know what my isotope is. So home, my isotope, zoom in, happens at -3, right? You can see it never touches -3. So -3 is my isotope. So again, you do need to go through the points apparently, but you don't have to be exact. I need to hit draw, done plot. All right, and my isotope is -3, so you just curve into your isotope. So look, just hit the points. I'm going to be crooked. Look, I'm crooked, right? Let's see if it'll let it do it. Then when you get to here, make sure you curve into -3. All right, go on forever in, that direction. All right, so let's see if it lets me. Yay! Okay, so again, it's not that sensitive. You see how I kind of did like a little squiggly line. Just try to go through your points and curve into your isotope with the arrow on both sides, and you should be great. All right, so that's how you do that. All right, so we're going to take a look at adding and subtracting radical expressions. I'll do both a subtraction and an addition one. Biggest thing to remember is that you cannot add or subtract until the radicals are the same. So if you look right underneath the radicals, those are called radicands. Is that the same right now? No. How about this one? No. So I cannot combine these until they are the same. To make them the same, you're going to simplify it. Okay. Now, if you're not good with your multiplication facts, remember you're going to check using a calculator 2, 3, just prime numbers, 2, 3, 5, 7, 11, and you can just keep going on. Okay. And I will show you how to do that with a calculator. So you're just going to have a calculator next to your work. All right. So what we're going to do is we're going to break this down into my cards, right? Because there is no such card as a 90, right? There's no card as a 90, so I need to break it down so I can have cards. All right, so I break it down by checking these numbers right here. 2 numbers multiplied together is going to equal 90. So I'm going to check 2. So 90 divided by 2 is 45, which means 2 times 45 is equal to 90. And I can just check that. 2 times 45 is equal to 90, okay? This is a prime number, so you circle it.
break 45 down. So you keep checking 2. When 2 runs out, you check 3. So I'm check 2 again. So 45 divided by 2. Oh my gosh, it's a decimal. So I no longer check 2. I move on to 3. So 45 divided by 3 is 15, which means 3 times 15 is equal to 45. 3 is a prime number. Break down 15. You keep checking 3. 15 divided by 3 is 5. So that breaks down to 3 times 5. 3 is a prime number. Can I break down 5 anymore? No, because it is a prime number. Therefore, I circle it. Don't forget to circle. So you should have everything at the end of the trees circled. You're going to repeat that same process for 160. So you're going to start off with 2. All right, so 160 divided by 2 is 80. So 2 times 8 is 160. Break down 80, divide it again by 2. 80 divided by 2 is 40. And I'm just going to keep doing that. I'm just not going to type it in the calculator. It's taking me a long time. All right, so divided by 2, half of 40 is 20. Divide that by 2, half of 20 is 10. Divide that by 2, half of 10 is 5. Can I break down 5 anymore? No, so I am at the end, so I circle that as well. All right, so this is called prime factorization. So that's what we're doing. We're finding our factorization tree. Now we're going to write out our question. So -9. Going to leave a little bit of space because we're going to take out some books. And in place of this 90, right? And actually, to double check our work to make sure we broke this down correctly, if you do 2 times 3 times 3 times 5, you have to get it back, 90. Because this is the same thing as that in card form, right? So this is 2 times 3 times 3 times 5. Okay? On this one, I have minus. There's nothing outside, but leave some space for your books. And then again, let me check this one. It has to be that when I multiply all of these, I get 160. So 1, 2, 3, 4, 5, and then times that 5, 160. So I know I did that correctly, so now I can write that out. So 1, 2, 3, 4, 5, and 1, 5. Okay, so when I multiply all this out, I get the same 160. So I didn't really change anything. All I did was make it into card form. So remember, the radical is my hand, right? Outside the radical is my book. So I'm going to give myself a 2 for the first one, 2 3s, and a 5, right? So the radical right here is my hand. What do you see? I see a book of 3. So 2 cards make how many books? 1 book. When you put it down on your left as 1. So I took my 2 cards, I put it down on my left as 1. In my hand, I still have my 2 and my 5. Any more books? No. Okay, I move on to my next question. So here I have 5 2s and 1 5. 5 2s and 1 5. Okay, 1, 2, 3, 4, 5, yeah. 5 2s and 1 5. Do you see any books? Yes. 2 cards make how many books? 1 book. So I put it down to my left. So 2 cards make 1 book times 2 cards make 1 book. So I put it down to my left. So now you can see I have 2 books of 2 outside. So I have 2 books of 2 outside. 2 cards make 1 book. All right, then I have a 2 and a 5 left. Can I make any books? No. So I got 2 books of 2 outside, and I have a 2 and 5 in my hand. All right, now, remember the question did not give it to me in terms of cards, right? It gave me actual numbers that were bigger than cards. So we got to put the numbers back into what the original question gave me. So we have negative on the outside here. We have -9 times 3, which is -18. Radical, 2 times 5, which is 10. Minus 2 times 2, which is 4. Radical, 2 times 5, which is 10. Well, what do you notice about the radicals now? So if you look at the radicals, what can you tell me? They are the same. So remember, you cannot add or subtract radicals until they are the same. So this is what I want you to think of, because you can actually give me this answer really fast. If I had -18x minus 4x, what would that equal? So you would just combine them, right? Negatives are meeting negatives, so more negatives. So that's going to be 22x. So if I have, oh, wait a minute. -9 times 3 is what? -27. I'm tripping, y'all. Sometimes you just get lost in this math. -27. So please use a calculator. Use a calculator. All right, so if I have -27 minus 4. So negatives are meeting negatives, more negatives. That's going to be -31. okay? Now, variables, I told you, are just like radicals. It's the same thing. You didn't touch the variable. You just added or subtracted the coefficients. So this is equal to negative 31, and I didn't touch the radicals because I didn't touch the variables in here, radical 10. So this is my final answer. So biggest thing to remember, when you're adding and subtracting, they have to be the same. These radicals must be the same. If they're not, simplify it first, and then if they're the same, you can combine them. Well, what if I get to the bottom and they're not the same? Then the simplified answer without you combining is the answer. All right, let me do addition. So that was subtraction, addition. It's the exact same process. It doesn't change anything. Again, these two are not the same, so I do have to simplify. So again, the numbers I'm checking are 2, 3, 5. I'm not going to show you the calculator anymore because it takes a long time to do it when you can just do it. So 12 divided by 2 is 6. 6 divided by 2 is 3. And can I break down 3 anymore? No. Can I break 3 down anymore? No. So this is it. So I'm going to write down negative 9, radical, leave a little space. Don't write in pen. Negative 9, leave a little space for your books. And then my cards are 2, 2, and 3. 2, 2, and 3. Plus, there's a 5 here. Leave a little space. And then a 3 here. So I'm going to give myself this hand. 2, 2, and 3. 2, 2, and 3. So what do you see? I see a book of 2. So 2 cards make how many books? 1 book. I put it on my left, right there with that negative 9. 2 cards make 1 book. And in my hand, I still have the 3. Okay, can I make any more books with just 1? No, I cannot. All right, so outside, I have negative 18. Inside, I have 3. Plus, nothing, no books here, so there's nothing I can do. So this is just 5, radical 3. And again, what do you notice about the radicals? They are the same. You can add and subtract them if they're the same. Now, if I had simplified this and the radicals were different, then the different answer would be the answer. All right, so think of these as variables so that you don't get confused. So negative 18x plus 5x, what would that be? Negatives are meeting positives. Negatives win by 13. All right, so negative wins by 13x. So again, you're just changing the coefficients. The variable stays the same, which means you just change the coefficient, negative 13. The radical stays the same. And that's how you add and subtract. So adding and subtracting, the radicals must be the same before you add and subtract. Multiplying and dividing, now you can make them the same before you multiply and divide. However, it's a lot faster just to multiply and divide. So we're just going to multiply and divide and then simplify after. The word product means multiply. So I'm going to rewrite this question. It says 6 radical 8 times 3 radical 24. And I'm going to give you a couple of different scenarios in case you get those. But first I'll do this. So if I had 2x times 3x, okay, what would you do? It would be 6x squared, okay? So what did you do? You did 2 times 3, which would give you 6, and then you did x times x, which would give you x squared. You're going to do the same thing with the radicals. The coefficient times the coefficient outside, and then the radical times the radical, okay? So the exact same process. So let's go ahead and get started. The outside numbers, 6 times 3, which will give me 18, times the inside numbers, the radicals, this times this. Now, you could go ahead and put those in a calculator, but because I don't want to use a calculator, I'm just going to leave it as multiplication because guess what? We're going to break them down into cards anyway. So this times this on the inside. Now, let me give you a few situations. Oh, Miss Ainley, what if I didn't have a number outside? Like, let's say I had radical 8 times 3 radical 24, right? Well, there's an invisible what out here? 1. So it's still 1 times 3 and 8 times 24, okay? Oh, Miss Ainley, what if there are no numbers at all? So what if I had this? Again, they are invisibles, ones right out here. So you would do the outside and then the inside. Okay. All right, Miss Ainley, what if I don't even have a radical? Let's say I had 6 radical 8 times 3, for example. I don't even have a radical. Well, imagine if there was one there, put it there. And again, you would do the outside first and then the inside. So the outside would be 18 and the inside would just be that radical 8. And then you go ahead and simplify. Okay, so it doesn't matter what the situation is. those would be what the steps that you'd follow. Okay, so back to the question. All right, so again, you could put this in a calculator and simplify it all at once, and you're going to see that if you do that method, it's fine. You're going to end up in the same place, but I'm going to keep them separate and do them together. So again, break down 8 for me. 2 times 4. Okay, break down 4 for me. 2 times 2. Break down 24 for me. 2 times 12. Break down 12. 2 times 6. Break down 6. 2 times 3. Can I break down 3? No, so that is me done. All right, I'm going to write this out. So I have 18. Inside the radical, I have all of these in order. Okay, so I got 1, 2, 3, 4, 5, 6. 6 2s and a 3. 1, 2, 3, 4, 5, 6, and a 3. Okay, so I'm going to give myself those cards. 6 2s and 1 3. All right, 6 2s and 1 3. So that's what I have right now. So tell me what you see. All right, so I see a book of 2s. So I put that to the left. Now, there's an 18 outside already. That's there. So imagine if there was a card called 18, right? It's already outside. When I put a book outside, so when I take this book and I put it outside, I don't put it on top, right? It's just outside already. I just put it next to it on the left. So I have a book of 18. Imagine that's 18. I just don't have a card that's 18. I have a book of 18 and a book of 2. So I take this right here, and it's already outside. That's fine. Now, in my hand, I'd have another book. So that's a book of 2. Put it outside. Put it outside. I have another book of 2. So take this, put it outside. I have a book of 2. All right, what do I have left in my hand? I still have a book, so we're going to take that out, and we are going to put it outside. So we have a book of 2, and we're going to put it outside. So I have a total of 1, 2, 3, 4. So I have 1, 2, 3, 4 books outside. 1, 2, 3, 4 books outside, and then I'm holding that 3. So we're just going to go ahead and combine them. All right, so put them in the calculator. So 2 times 2 times 2 times 18. And that's going to give me 144 outside. Radical. And inside, I have nothing to combine. I only have the 1 card, so just 3. Okay, so 144, radical 3. So now we're going to do the same thing with division. It's just the same as multiplying, but instead of multiplying them, you're dividing. Again, you have to do outside with outside, inside the radical with inside the radical, right? So let me be mindful. If I had, let's say I had, actually, I'll do this. I'll do this first, and then I'll come and give you different scenarios, okay? So again, inside the radical divided by inside the radical. Because these are both radicals, I can divide them. So 2,000 divided by 8 is going to give me 250. And then again, after you divide, you simplify, right? So I've divided, now I just simplify. So 2 goes in 250, 125 times. 2 goes into 125, it doesn't. 3 doesn't. So again, you just go 125 divided by 2. Decimal, so that doesn't work. 125 divided by 3. Decimal doesn't work. 125 divided by 5. 25. All right, so 2. So it's not 2, it's 5. 5 times 25. And then 5 times 5 is 25. And I can't go any further. So this 250 is going to become, I'll leave a little space to get my books. 2, a 5, a 5, and a 5. So I've got 1, 2, and 3 5s. So again, I get my cards. 1, 2, and 3 5s. What do you see? I see a book of 5. So these 2 cards are going to become what? 1 book on the left, right? So these 2 cards are 1 book on the left. I have 2 and a 5. Any more books? No. So I just stayed just like that. What do I have outside? Just the 5. So this is going to be 5 radical, and we got to combine these back. So 2 times 5 would give me 10. And that's pretty much all there is to it. I'm just going to give you a couple more examples in case they give you different ones. So you see, it's a radical divided by a radical, right? But let's say they gave you a radical, let's just say 24. Divide by a number. Can I divide these two? No, because this is a radical, this is inside, and this has, you can imagine, nothing, right? So what you have to think of is you have an invisible 1 right here, right? So invisible 1 divided by 2 is still going to be 1/2. Then radical divided by, there's nothing there, so this is just the radical. So radical 24. Now you have to simplify. So that's my division. Now I have to simplify. So break 24 down. 24 divided by 2 is 12. Half of 12 divided by 2 is 6. Divided by 2 is 3. Can I break down 3? No. So this is it. So this is going to be 1/2, because there's that half, and then radical, and leave a little space, take the books out. 1, 2, 3 2s. 1, 2, 3, and a 3. Okay, so once again, what do I have? I have 3 2s, and a 3. Boom. So what do you see? I have a book of 2s, so 2 cards are going to make 1 book. So 2 cards are going to make 1 book outside, so you multiply that. All right, then I have a 2 and a 3. Any more books? No. All right, so now I'm going to combine the outside. 1/2 times 2 is going to be 1. Okay, I'll just write it over here. And then 2 times 3, because it's not a book, 2 times 3 is going to be 6, which simplifies this as an invisible 1 to 6. So the big idea is you're going to multiply or divide inside with the radical with inside and outside with outside. Okay, so don't combine them when they're not inside, both inside or both outside. All right, and the last one we're going to look at is the sum and product of rational versus irrational numbers. Biggest thing that you need to know is the definition of what rational and irrational is. So we're just going to quickly go over that. Rational, all right, can be rewritten. These 3 things must be true, okay, for it to be rational. All right, these 3 things must be true. It can be written as a fraction of integers. What does that mean? You have like a number 5. And 5 divided by, if I was to write it as a fraction, it would be what? 5 divided by 1, right? That's a fraction of integers, okay? 5 divided by 1, 1 over 3. That's a fraction of integers. What is not a fraction of integers? If I have radical 3 divided by 2, because radical 3 is not an integer. What about 0.2 divided by 4? 0.2 is not an integer. So again, for it to be rational, these 3 things must be true. Second one, it can be a repeating decimal, okay? That means 2.32222222222 repeating decimal. What is not a repeating decimal? So what's an endless non-repeating decimal? It's irrational. 2.321432. There's no pattern. It's not repeating. It keeps changing, okay? That's irrational. And then finally, it can be a terminating decimal, meaning it could be a decimal that's not repeating, but it finishes, right? So 2.323, it's not repeating, but there's an end. All right, so rational number has these 3 things. If it goes on forever, it is not terminating, like pi. Pi is 3.14, blah, 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 and going on forever, it doesn't terminate. So once again, in order for it to be rational, these 3 things, all 3 things must be true. It can be written as a fraction of integers, it can be written as a repeating decimal, or it can be written as a terminating decimal. Now, what you have to be careful is when you're looking at a fraction of integers, sometimes the radical simplifies. So first you got to simplify it and then see. So if you simplify it and it's still not an integer, then it's irrational. If you simplify the radical and it is an integer, then it's rational. So rational versus irrational. These 3 things must be true. So we're going to take a look at a couple of examples just to make sure you understand it. Going to finish off the sum of rational and irrational numbers now that you know what the definition is. So with this one, don't just assume because it's a radical, it's not a fraction of radicals. It could be. Okay, so you do kind of have to look at it. So is the product of these 2 rational or irrational? So that means I got to do what? I got to multiply them out like I was doing before. So there's an invisible 1 right here. So this is 1 radical 13, excuse my bad handwriting, times 4 radical 7. All right, so multiply the outsides. Multiply the outsides. 1 times 4 is 4. Multiply the insides, 13 times 7. And just, pull up a calculator and do it with a calculator. $91. All right, can I simplify 91? So I check 2. I'm checking 91. So I'm going to check 2, 3, just prime numbers, right?
So 91 divided by 2 doesn't work. 91 divided by 3 doesn't work. 4. Sorry, we don't need to check 4. 5 doesn't work. 7 works. All right, so 7 times 13, and duh, because we had just done 7 times 13. So 7 times 13, so this breaks down to 7, which is a prime number, and 13, which is a prime number. So I'm going to have 4 radical 7 times 13. Any books? No, no books, nothing to take outside. So I just combine it back because there's nothing else, there's nothing to take, no books outside. So it's still 4 radical 91. And this is not an integer of numbers. So because of that, so let's go ahead and put this in. 4 radical 91. So 4 radical 91. This is not an integer. It's irrational because it cannot be written as a ratio of 2 integers, and its decimal expansion does not terminate or repeat. And I'll just prove that to you really quickly using the calculator. So it was 4 radical 91. See, it doesn't repeat, and it goes on forever. If you can't simplify the radical, then it is irrational. If you can simplify the radical, then it's rational. All right, I will do a couple of these just to make sure that you're okay. So the product of these two numbers, so let's go ahead and do that. And as soon as you're comfortable, you could go ahead. So we have 5 radical 6 times radical 14, and again there is an invisible one right here. Multiply those two, so that's going to be 5. Multiply these two. Now I'm going to leave it as this 6 times 14 because, as we saw, it's just faster when you're breaking it down. So this breaks down to 2, which is prime, times 3, which is prime. 14 breaks down to 2, which is prime, and 7, which is prime. So I have 5, leave a little space for your books, and then in order I have 2 times 2 times 3 times 7. All right, what do you see? I see a book of 2, so I put that outside. Anything else? No. So I'm going to have 10 radical, 3 times 7 is 21. And again, because we still have a radical, so 10, 21. So the result is 10 radical 21. And it is irrational because I still have this radical. And again, I will go ahead and prove it to you using a calculator. 10 radical 21. So 10 radical 21. See, it's not repeating, and it's going on forever. So it's irrational because it cannot be written as a ratio of 2 integers, and its decimal expansion does not terminate or repeat. Okay, I'm trying to find one that does so that I can do that question. New problem. So I'm going to kind of cheat. Okay, here's one. All right, so let's do this one. All right, so I want to show you one that is rational. All right, so once again, this is the sum. So be careful that it's going to keep changing. So this is addition. So we have 5 radical 4 plus 2 radical 9. All right, now remember, you cannot add or subtract until these radicals are the same. And right now, are they the same? No. So what I have to do is simplify them in order to make them the same, right? So 4 breaks down to 2, which is prime, times 2, which is prime. This breaks down to 3 times 3, and they're both prime. All right, so that becomes 5, leave a space for books, and then you have 2 times 2, plus 2, leave a space for books, and then here you have 3 times 3. All right, and then what do you see? I see a book of 2s, so 1 book of 2. Here I see a book of 3, so 1 book of 3. So I'm going to have 5 times 2, which is 10, nothing with the radical, plus 2 times 3 is 6, nothing with the radical. So this is just, you can just ignore the radicals because they're actually not the same. So you have 10 plus 6, which is 16. So this is 16. Okay, yes, this is rational because it can be written as a ratio of 2 integers, and its decimal expansion does terminate or repeat because it's 16.0. Okay, so again, the 3 things that have to be true about rational or irrational numbers is they can be written as a fraction of integers, the decimal terminates, or the decimal repeats. If it doesn't do one of those things, then it's irrational.